Welcome to the lesson on angles. In this lesson, we will discuss one of the most basic concrete figures and units in geometry and how they'll apply to various problems. Unlike points, lines, or planes, some terms in geometry are clearly defined and measurable. We have a line segment, which is defined as a subset of a line with two endpoints. I can draw a line segment here to show you how I have two defined endpoints and the line between it, and it only goes from A to B. I also have a ray. A ray is another subset of a line, but instead of going from one endpoint to the other, a ray starts at A and continues through B and goes in that direction infinitely. Now, an angle is a union of two rays. Those rays have a common endpoint, and both rays continue indefinitely in the other direction. So I can have 3 points, and of course each of those points has a title A, B, and C. B is that common endpoint for both of these rays. Now, it's also very important to consider how we name our angles to distinguish them between each other. Angles are named for their vertex and for one point on each ray. So taking a look at this diagram, I can examine the 3 points I have and consider that I could name this angle X, Y, Z. But at the same time, I could decide to go the other way and name it Z, Y, X. Now, what these two names have in common is that the Y is in the middle, and the Y must be in the middle because the Y is the vertex. The Y is the vertex of this angle, so regardless of whether the X or the Z comes first, the Y must be in the middle. In this case, I could simply name this angle angle Y, because Y is the only angle that vertex has. Now, in this other diagram, I couldn't call this angle angle X, because X is the vertex of several angles, so I'd have to cross that out and end up being more specific and use all the letters, such as A, X, B, or I can have the angle right next to it. I could have angle B, X, C, and I can even pick a different angle, C, X, D. Whatever I choose, I must make sure that X is the vertex. Now, angles can also be classified into several types, and we think of these angles by their measure. We group them by their measure. So we first think about an acute angle. An acute angle is an angle whose measure is less than 90. So most acute angles, although they can be very large and close to 90, will generally look pretty small. Now, an obtuse angle is any angle whose measure is greater than 90 and typically less than 180, of course. So an obtuse angle will have two very wide set rays. A right angle is an angle whose measure is equal to 90. A right angle, and you typically draw it, you have the right angle symbol of a box. We also have a straight angle, an angle whose measure is equal to 180. A straight angle, it looks like a line, a point in the middle, and you can have a point on either sides. And then lastly, we have a reflex angle. Now, while we won't talk about these that much, it is an angle whose measure has been greater than 180 degrees and appears larger than a straight angle. Now, angles also get classified by their pairs and the special relationship that an angle might have with other angles around it. The most basic classification could be the adjacent angles. This could be any two angles that are on a line that are simply next to each other. They share a vertex and they share a side. They share a ray together. So there doesn't have to be any other special characteristics other than them just being next to each other. Now, complementary angles are angles that do add up to 90 degrees. And while they don't have to be part of a diagram like this, and they could be completely separate, at the end of the day, angle A plus angle B will equal 90. Now, in much the same way, supplementary angles will always add up to 180 degrees. Now, typically, when we look at a supplementary angle, we are talking about those angles that appear together and next to each other on a straight line. Now, with these special relationships defined, we know that we can go ahead and apply algebra to this scenario. I can take two angles next to each other and say that one side of this angle is represented by 5x and the other side is represented by 2x, and the question could be to find x. Well, by creating an equation where I add those two expressions, 5x plus 2x, I know that those two expressions represent angles that would add up to equal 180, and I can simply do the algebra from there. Now, before going forward, it's important to consider a special key word, and that keyword is congruent. Now, anytime that we have angles that are equal in measure, we of course have to recognize that those angles are congruent, and those angles can also be any of the other characteristics we talked about. The most common pair of congruent angles that we'll probably see would be vertical angles. Angles that are across from a common vertex end up being those vertical angles that are also congruent. So let's do some practice so we can apply some of these rules. Let's say from this diagram, I can infer that, well, these two angles are complementary and adjacent, so that means I can add those two expressions and set them equal to 90. So 90 equals 4x plus 8x plus 6. So now I can combine some like terms, and 90 equals 12x plus 6. I'll go ahead and subtract 6 from both sides and get 84 equals 12x. And when I divide both sides by 12, my x will end up equaling 7. Now if I take a look at another type of problem, in this question I have to find the measure of angle CBF. So let's say I'm working to find the measure of angle CBF. In order to do that, I first have to find x. And in that case, I'll go ahead and make sure that I can set 3x plus 14 equal to 6x minus 40, because those two expressions are representing angles that are congruent because they're vertical, as we discussed in the last segment. So by combining like terms, I bring the 3x to one side, the 40 to the other, and I get that 54 equals 3x, and that x equals 18. Now, even though I have that x equals 18, I can't consider the problem finished. The question did ask us for angle CBF. So angle CBF, being represented by a 6x minus 40, would be what we'd have to plug our 18 into. So 6 times 18 will give us 108 minus 40, and then 108 minus 40 will give me 68. So 68 is the measure of that angle CBF.